Hey, Math Analyzers, welcome to your Chapter 10 overview and your Chapter 10 Lesson 1 lesson. So, what we're going to be looking at in Chapter 10 is all our trigonometric functions. We're going to review today very quickly our basic graphs of sine and cosine. Then, what we're going to do in lessons 2 through 5 is we're going to slowly move our sine and cosine functions around our graphs. So we'll raise them up and down with our amplitude, we'll squish them or widen them with frequency and period, and vertical shifts will move them up and down. Horizontal or phase shifts will move them left and right. And when we get to that lesson 5 with the phase shifts, what I'll show you is you move your cosine slightly left or right, and all of a sudden it becomes sine again, which is why I'm going to start calling these two, the sine and cosine graphs, sinusoidal functions, because they both they're just slightly off from being one another. Then, of course, we review and have a quiz on just that, moving the functions around and looking at the equations and moving them around. We'll model them. We'll look at the tangent function and see how it's so vastly different from the sine and cosine functions we've been working with. We'll introduce 3 new trigonometric ratios, which are secant, cosecant, and cotangent. We'll introduce those. We'll work a tiny bit with those, and then we'll just in lesson 9 identify their graphs. Okay? So here we go. Let's just review our basic sine and cosine graphs. So we know from our chapter 9 that the sine and cosine functions actually come from unraveling that unit circle over an XY axis that's really your radians as your X value, and then your Y value being where on the unit circle is this point, right? So same with cosine. Cosine is the one that looks like the cup. This is each of these coordinates at these radian measures. So that's why all these stack up, and that's why we needed to know those special right triangle relationships to understand where are we on the circle at each of these places. This is the sine, which is our y coordinates around the unit circle. This is our cosine, which is our x coordinates around the unit circle. And that's what gives us these two functions to actually then call our sinusoidal or trigonometric functions. Okay, that's what these are. So again, just a reminder, when you're unwrapping the unit circle, your x in this axis, in this xy axis, is actually your degree or radian measure throughout. And your y is what are we looking at? The sine function is the y value in each point, and the cosine function is the x value in each point. And so you do see those curves that are occurring in that. Okay, in that vein. And, y is the vertical side, x is the horizontal side. And so that's what you know when you're putting these guys up there. Okay, vertical side of the triangle, horizontal side of the triangles, each way around. Okay, so that's what we had talked about at the end of chapter 9. So since this chapter is going to be manipulating these two functions, the entire first part of this chapter is manipulating these two functions. Since that's the case, let's just review how to graph these two functions, okay? So we'll start with sine, the very basic sine function. That's all we know how to do at this point, and that's all we're using. So the first thing I'm going to do is just convert degrees into radians. So 0 degrees is 0 radians. Then we've got pi over 4 radians, pi over 2 radians for 90 degrees. 135 is 3 pi over 4. 180 is pi radians. 225, so we're just on the other side there. That's 5 pi over 4, just on the other side of the circle, down kind of bottom. This is 3 pi over 2 for 270. We've got 7 pi over 4 for 315. and then we've got 360. And a lot of times when we graph the trig functions, we graph them in radians for our x down here, okay? So that's the reason that we do need to know that conversion from radian measure into degree measure. What's the matching sign in each of these points as we're going around the unit circle? Well, these are all at 45s. These are either at your intersection points around your coordinate plane, your XY axes, or these are that middle, quote unquote, point of the unit circle, which means radical 2 over 2. Careful of which quadrant you're in when you're determining the sign of that radical 2 over 2. Okay, so what I mean by that is at 0 degrees, so kind of think of your unit circle, and that's a terrible circle sketch, but you get the idea. Right here at 0 radians, 0 degrees, we know that this point is 1, 0. So my sine value is the y part of the coordinate. That would be 0. So at 0 radians, we're at 0 for sine. At 90 degrees up here, right, this point is 1, 0. So that means that for 90 degrees, our sine is 1. Thank you. 0, 1. It does mean our sine is 1 because that's our y coordinate. Then at 180, so right down here, let's get this right, negative 1, 0. So that means our sine is back down to 0. And then down here at 270, or 3 pi over 2 radians, this point is 0, negative 1. So that means our sine is negative 1. It goes all the way down there. And then, of course, back up here, 2 pi radians is the same as 0 pi radians, which is what makes that cycle that happens. And so what that means here is that we're back to 0 as our sine value. And as long as your graphing calculator is in degree mode, which I just had to put mine in, you can actually check that, right? So if sine of 0 is what I want to know, I can plug in here and check it. If sine of 270 is what I want to know, I can plug in here and check it, okay? Now, of course, what I skipped over was all these special areas around the circle, and they are all these points around that circle because those are all the 45-degree reference angles, okay? As we know, at the 45-degree reference angles, they are always radical 2 over 2, and it's just dependent on which quadrant we're in as to the sign of that radical 2 over 2, okay? So in quadrant 1, of course, the radical 2 over 2, the y value of that coordinate is positive. And we use radical 2 over 2 because it's the exact measure. If you want to plug sine of 45 into your graphing calculator and check it, you get this value, right? That decimal, that non-repeating, non-terminating decimal. So just to prove to you that this is indeed radical 2 over 2, I'm just going to type that into my graphing calculator and show you that these decimals come out to be exactly the same. It is just a heck of a lot easier to represent that as radical 2 over 2 because that's its exact value as an irrational number. Okay. Then, of course, in quadrant 2, y is still positive. We're still up. So y is still positive. So what that means is radical 2 over 2 here is also still positive. But I just want to show you. You start at 0, up to radical 2 over 2, up to 1 is your max, then back down to radical 2 over 2, and back down to 0. So that's the first curve that's above our x-axis for our sine curve. Then, of course, we head to the third quadrant where y becomes negative. So now you've got negative radical 2 over 2. And we head down even further to negative 1. That's our min, our low point, our minimum point. And then we come back up the curve, back up to 0 again. And that's this infinite cycle of sine doing the exact same thing that's going on in the unit circle. So now I'm just going to put that on the graph down here. It's the unraveling of the circle at the y's. So we start at 0, 0, I'm just going to scale so I go up here and down here. So +1, -1, just to give myself a little space, right? So I know that at pi over 2, that's 90 degrees, I am all the way up at 1, and that's my max. I know that pi, or 180 degrees, is back down to 0. I know that 3 pi over 2 is 270 degrees, and I'm all the way down to my minimum at -1. And I know that 2 pi is back up to 0. That's my 360 degrees back to my start point. So that's how I know these two are starting and finishing. Now, the in between, of course, halfway between this is pi over 4. So the reason that we chose 45s as our special right angles that we were using here, our special angle degree relationship that we were using here, is because those are exactly halfway between. So they're a little bit easier to guesstimate on our graph, right? And we know that since radical 2 over 2 is 0.707, we know that this is a little bit, this would be 0.5, right? Halfway. So we know we're about here, right? Getting close to the curve when we're heading up. This is quadrant 1 and 2. So quadrant 1, axes, quadrant 2, back down, axes, right? Then this is quadrant 3, so right about here. And then back all the way down. And then quadrant 4, right about here. Okay, and then connect in a nice curve. Nice curve sketch just like that. And when I talk about that infinite cycle of sine, if I want to go maybe in these negative realms like we've done, all I need to do is just carry that backwards, right? That's all I need to do is carry this backwards. So I know that this will be my minimum right here. This is the match to 270. This will be back to 0. This will be my maximum. This will be my match with 0. And so I know I can still sketch in exactly the same fashion that I was just sketching, because it's this infinite cycle, and then connect back. So kind of once you know, and this is why we do the unit circle so intensely, is once you know, this is just that constant infinite cycle, and that's all you need to keep repeating. So if I want to sketch the sine curve in the positive realm from 0 to 4 pi, okay, this is my 0 to 2 pi. It's just another one of these heading to 4 pi. So if I just go pi, 2 pi, 3 pi, and 4 pi radians, again, this is radian measure, how many radiuses of my circle I've got in these places. These will be my halfways. So these will be all my 90 and 270s, right? Those will be all my 90 and 270s. And if we're going that other, if we're going the 45s, halfway between those, right? So let me just label those, pi over 2 and pi over 4. So we know what each of those hash marks is as we're going and scaling. And again, this is just a cycle, and this is just a sketch. So I'm really just kind of trying to get an idea. If I want to go all the way up here for 1 and all the way down here for -1, that'll be my max and min. I know that we start at 0, 0. I know we get to 0 again for pi, which means that 2 pi, 3 pi, and 4 pi all get to 0. Okay, and everything else is the in between. At 90 degrees, we get to our max. And at 270, we get to our min. So that means over here, past 360, here is our max first. Our min is second. Okay, and then that's the curve that we're looking for. So I'm just going to kind of sketch these in. Oops. I was a little too far down there, but that'll work. And then I'll just sketch those in. And then just keep curving, just like this. And that sine function kind of looks like the sideways S. That's how I always remember them. Okay? if you want to look at that on your graphing calculator at all, you can press y equals and type in sine of x, okay? But if you want to see this on your graphing calculator, well, you need to press zoom 7 for trig. Because what that will do is it will actually kind of zoom into and use our radian measure as our points that we're touching as we go. So it's changed my axis to be in radians on my x scale and regular numbers on my y scale, okay? So that's why we're going up to 1 and down to 1. And that's that infinite cycle that we're looking at. Well then, on to cosine. So cosine, of course, is our kind of cup, right? Cosine, just slightly different, kind of our cup deal. And this is the x coordinates from our unit circle. So if I sketch the unit circle again, much better circle that time, well, other than that part, right? If I sketch the unit circle again, and I'm looking at my points all the way around, this time I want to steal my x values from each of these points. So this time I want 1 to start out. So that's why cosine starts high, right? Cosine starts high. And then at 90, it's 0. So that's why we go down to 0 and then keep going down to -1 and then come back up to 0. And at 360, the end, that's why you get back up to your 1. Now, again, these in-betweens for the 45s are still all radical 2 over 2, but this time it's what's the sign of the x coordinate in each of the quadrants. So this time it's, yeah, in quadrant 1, radical 2 over 2 is positive, but in quadrant 2, the x coordinates are negative. So this is negative radical 2 over 2. And you think about it, we've dipped below the x-axis at this point. So now we're get to our minimum and we come back up because cosine is and x is negative in the third quadrant, and then we're back above and positive with our x values for the fourth quadrant. So that's why cosine does the cup kind of thing, where it starts high, and I'll put my scale exactly the same, starts high, middle is your minimum, and ends back up high. So now the in-betweens, the pi over 2 and 3 pi over 2, the 90 degrees and the 270 degrees, those are your zeros with cosine. Okay, so we're just slightly moved over, if you think about it. And that also means that since we can go halfway for our pi over 4, our 3 pi over 4, 5 pi over 4, and 7 pi over 4, because we can go halfway here, we know that this one is kind of up here, but this one is way down here. This one matches up and then back up. And so we see that curve, the unraveling. You can see it happening, but it looks more like the cup shape. And again, follow that backwards if we want to go back into the negative radian measures, right? So just follow it backwards. So that would mean that negative pi over 2 and negative 3 pi over 2 are still your zeros. This time it does mean that negative pi is also our minimum, and that negative 2 pi comes back to be our maximum. And then we'll have those in-betweeners, right? So our in-betweeners and sketch. Ooh, I don't usually go right to left when I sketch. That felt interesting. Sketch back. There's cosine. So sketching cosine moving just forward and not negative radians. If we're sketching from 0 to pi over 4 pi, okay, so then each of these is a pi, right? Pi, 2 pi, 3 pi, and 4 pi. That means halfway points are 90 degrees, so pi over 2 and 3 pi over 2, 270. And then after 360, adding 90, right? So we're getting to 450. That's what these guys are. 5 pi over 2, 7 pi over 2. That's what these guys are. These like extra circle, right? And then in betweens, there's your 45s, these in betweeny guys. Okay. Here, let me get a max and a min. Now remember, start high. Start high. Pi is low. Back up to, so your pi over 2s are your zeros, and then back up top for 2 pi. So then 5 pi over 2 is low. Nope, he's a 0. Thank you. 3 pi is low because regular 1 pi is low, so 3 pi is low. Perfect. And then back up here for middle, and then back up here. So now we just kind of sketch for our cosine. Sketching in my 2 pi over, radical 2 over 2s. And connect. And as we connect this curve here, we do really get the sense that this is just like the sine curve, exactly like the sine curve, just kind of scooched over, right? You can see it if you start looking just here to here, right? Or even better, just here to here. You can see that sine curve. So if you wanted to check this guy out on your graphing calculator, we can do the same thing. In fact, I'll leave sine and I'll head over here down to y2 for cosine of x. And zoom 7 gets me my trig look. So it's just going to regraph sine in the blue, and you can contrast it with cosine in the red. And you can see that it's just slightly over, but it's doing the same thing, right? Okay, it's doing the same thing. Now I'm just going to go back to y equals and turn off the blue so you can just analyze cosine. I'm just going to turn off that equal sign, and now here's your cosine. So you can see if you start high with the 1, dip down low, back up. And that's cosine. I always like to say sine is that sideways S, and cosine is the cupping that you're looking at. Okay? Just review. We've already done these. And our beautiful unit circle. What it all stems from. We'll practice one more time, just making sure we can easily graph sine and cosine and know which one is which. And after that, we'll start manipulating them. We'll start moving them around a little bit, but again, slowly. We'll manipulate them slowly. All righty, math analyzers. This was your chapter 10, lesson 1. I will be seeing you soon for amplitude. Bye.